did our stuff yesterday, remember how I said that if I was starting up front here and I wanted to get to the back row, it was what, 12 squares, I believe? Yeah. So midpoint, what do you think the midpoint would be? 6. Because if you think about it, midpoint sounds like the midway or the halfway spot. So what a midpoint does to a segment, the midpoint is the halfway spot on a segment. So if we have a segment, I'm going to use another term here in a second. For example, if I say that B is a midpoint, I'm guessing you guys, nobody flinched when I use MDPT for midpoint. So I'm assuming you guys are okay with me abbreviating it like that. Does that make sense though? So if I say B is a midpoint of AC, that means the segment AB and the segment BC have to be equal to each other. All right. So what midpoints do, they create two equal segments. Now, when you have numbers can be equal to each other. 3 is equal to 3, 7 is equal to 7, 44 is equal to 44, and so on and so on. When you get segments, angles, things that can be measured, things that have equal measurement are called congruent. All right? Things of equal measurement are called congruent. So this is a new term here. We're going off to the side. Congruent. Things with equal measurement. Congruent. Things with equal measurement. What's this? That's a desktop, right? You okay with that? Okay. What's this? Okay. Still a desktop? Yeah. All right, so are they the same size? No, I'm not yelling. I love the fact that you thought you were guilty of something. I was yelling for freedom. Are these desktops the same size? Are they the same dimension, shall we say it? Or they have the same dimensions? In theory, they should because they were made in the same place, the same time-ish, but they have the same die cut and whatever. So these desktops, being the exact same measurements, same sizes, same lengths, they would be called congruent. Okay? That's where that comes from. If you must, just don't poke yourself in the head. Like you? Sorry. So, I'm sorry. So what happens here is, I'll come back to this in 1 second. What happens here is that you get segments can have the exact same measurements. If each of these segments were 14 inches, I don't know, I'm making stuff up. If those two segments are equal, and let's say this is segment AB oops, sorry, AB, and this is XY. When we say that if two things have equal measurements, segments or angles, things like that, we would say that segment AB is congruent to XY. That symbol there, the equal sign with the squiggly over it, stands for congruency. It means they have equal measurement. What you will see within diagrams then will be this thing called a tick mark. Those share one tick mark, meaning they have the same length. Okay? That's where this comes from. If you go through, so you guys know what these are? They're grout lines. Okay, they're grout lines. The grout that's in here when they use cinder block is usually cement. Okay, whereas if you have tile, it's still kind of a cement base, but they call it grout. It's a little bit different. So if you're looking at it, I measured this through. This grout piece here is 7 3/4 length here. Okay, 7 3/4. That's also 7 3/4, which means that these two segments would be the same. So that means they would be congruent. So from here to here, here to here, those would be the same. I would mark them with a tick mark. That's what that means. Okay. Yeah. Nope. Now, if you look up on the whiteboard, I drew during second hour. I drew two triangles. Now, when you have triangles, you obviously have three sides to a triangle, and it is completely possible to have each side length be in a different measurement to have the triangles be having side lengths be congruent. We talk a whole bunch about congruencies within triangles and ways of showing how it works in a couple of months. Okay? But that is stuff that we will do. But again, the idea here is this symbol called congruency or congruent, and it's how to show that things are equal in measure. All right? Now back to the midpoint then. If B is the midpoint of AC, that means it cuts the segment into two equal parts. It's the halfway spot, which means that segment AB and segment BC have to be what to each other? Equal and congruent. Very good. So what I could do with my diagram is that. Which means that if my segment my segment AC is 24 inches long, how much is each segment? 12. Exactly. It cuts it in half. Yes, sir. Yes, sir. Yep. If you have the term called midpoint, then it works. Whereas yesterday we were saying stuff, we were talking like you had two segments that would add up to equal the whole. Well, you still have that, but this just becomes a little bit more specific because you know that it is that both parts would be equal. Whereas yesterday it was 8 and 4. Not terrible, is it? So like I was saying, you're going to see stuff where you'll have a segment, it'll say W, X, and Z. It'll say X is the midpoint of WZ. And then if it gives you this being 13, what is XZ and what is WZ? If it tells you that X is the midpoint, that means you have two congruent segments, two equal segments. Excuse me. When I go and mark my diagram then, what two segments have to be equal to each other, congruent to each other? Very good. It means that WX and XZ have to be the same. Which therefore, if WX is 13, what's XZ? 13. And then, do two smaller segments equal the whole? And what's the whole thing? There you go. So it's not that difficult. What we're just looking at is a new vocabulary to help us do some algebra. That sounds like an ongoing theme. Vocabulary to help us do algebra. It's kind of what geometry is. Okay? I know, right? Q is the midpoint of PR. What we're going to do is we need to figure out how to solve for those three lines. Now remember, yesterday, you were given overall dimension, or parts of the dimensions and stuff. Here, all we have is the algebraic, but you have a definition that you can work with. So we have segment PQ, or segment PQ and QR. Those 3 points are collinear. They're all in the same line. I know that PQ is 6x minus 7 and QR is 5x plus 1. But the very moment I put in that term, Q is a midpoint, that means what with the two segments? Very good, they're equal. So in my diagram, what I would normally do is this. I would just put a quick tick mark in, knowing that they have to be the same. Algebraically then, what do I do to solve for x? How? What's the equation you're going to write out? Exactly. That's the whole idea here. Because they're midpoints, like you just said, that they're equal to each other. So all we got to do is write it out. 6x minus 7 equals 5x plus 1. By definition, since those two guys are congruent, they are equal in measure, they have to be equal to each other. Now you're at a really fast two-step equation. We have variables on both sides. Remember, I always say pick on the little guy first. So what? Well, I was working with the variables. You're not wrong if you want to start with the 7 first. There's nothing wrong with that. I'm always in a habit of moving my variables first. Yeah. If you did the minus or add 7, you're not wrong, because then you would move the 5x later. Do you guys hear what I was saying on that one? It was asking, can you move the 7 to start with? Absolutely, that's fine. It's just more common for people to start with the variables first. But it's not that you're good. I mean, as long as you math it correctly, it's fine. So algebraically, subtract 5x from both sides. I get x minus 7 is 1. Therefore, x is 8. Yesterday we talked about this. Before we talked about this. Before that we probably talked about this. Geometry isn't just solve for x, it's do something with it. What do I have to do with those values with that value of x? Yep, gotta substitute that thing back in there, okay? So what was 6 times 8? 28. Subtract 7, you get? I thought you said 28 or something. I'm old, my hearing's bad. Too many concerts. And then I do the same thing with the 5 times 8. I get 41. So PQ, 41. QR, 41. And you're done. Okay. Again, the algebra isn't difficult. It's just using that vocabulary of the word midpoint to set it up. Good. I hope so. A one of the reasons that I always show this problem is because you're a year out of algebra and you probably don't remember some of the things that occur from time to time in math. For example, in this one, we know that these two guys have to be congruent because of the word midpoint. Midpoints create congruent segments. So we mark them. So now I know that the segment has to equal the segment, so I have 3x equals 5x minus 6. Now, what we've been doing over time here is we've been just taking on the little guy and subtracting, in this case, 3x from both sides. So if I do that, what do I have on the left now? 0. That's okay. Because now you still have a two-step equation. What do you do first? Add 6, good. Add the 6. What's 0 plus 6? 6. And now what do you do? Divide it by 2, and what do you get? And there you go. So now you've got your value of x. What do you do with it? Substitute back in. So when I do that, what's 3 times 3? And 5 times 3? Subtract 6. And hopefully you get 9 for both segments. Again, if you don't, you know you done goofed. And then just fill in your answers. 9, 9, 18. Okay. What did you do first? Did you subtract 5x? Perfectly fine. No, not wrong then. There's when you have equations, there's more than one way to do it correctly. I tend to stay away from subtracting the larger because then you get negative, and then sometimes what people will forget when they rewrote that -6, they'll forget that was negative. But you didn't, so that's good. So that's why I try to stay away from doing it that way. But it's fine. It's good. Nope. As long as you math it correctly, you're going to be fine. Okay. The trick with this is that I think I said this before. You could get negative values of x, but you should never get a negative segment length. You can walk backwards, but you're just walking a different direction. You're not walking a negative distance. Same thing with an angle. You can have a negative angle. Negative angle just goes the other direction, versus positive angles go this way. So it's not that it's incorrect, but it's, you don't worry about it. I think there's only, let's see, what was the other one on there? The only other thing that I wanted to show you with some of this stuff was this. And I don't want you to draw out this entire picture here. I just want you guys to think. In order for us to tell whether or not these two segments are congruent, so is segment JK congruent to segment LM, that means that those two segments have to be the same length, right? They have the same distance. So when you're on a grid or you're on a number line, how do you find distances? You count. I know. I know, this is a lot of brain stuff going on here today. So I'm hoping you guys, it's not gotten too late in the day that you can't help me here. So this is how I learned how to count. Ready? 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7. What, are you embarrassed now? No. You had your hands in your head to go to, oh, it's your nice transfer. I actually, that did go through my head for like a second. That really hurt. Wow, do you want to take the knife out of my back, please? I mean, I hadn't been like even remotely mean to anybody yet. Well, yeah, that was too. I mean, come on, that was on a silver platter. He's an idiot. I know. At least you know that 7 is more than 6. Wait, we have to explain this again? I'm sorry. Not really, but it's funny. Anyway, let's count again. Ready? Help me. Ready? 1. Come on, ready? 1 little, 2 little, 3 little spot. 4 little, 5 little, 6 little spots. 7 little, 8. Is 7? Now this one's a good one for you. I know it's tricky. I know it's early. Well, it's almost noon, so you may be all right now. Is 7 equal to 8? I know he's gonna be mad at me. I'm sorry. I'll stop. So are those congruent? I believe you're correct. That's really all we're looking at. Now, tomorrow, what we'll do is we'll continue the idea on grid and how we can find segment lengths and stuff like that. But what we're going to work with is we're going to use stuff that you have seen in the past. When you did this before, you guys found, remember using distance formula? There's distance formula stuff. There's actually a shortcut. I'm going to show you guys a shortcut tomorrow. We're also going to look at grid stuff like this, where it's not always horizontal or vertical. Well, we'll be able to find the midpoint of something just by looking at the ordered pairs. When it's diagonal like that, it's sometimes very difficult to look at that and locate the actual ordered pair. But there's an algebraic way of doing it. And again, it's super simple to do. So when I was looking at the calendar trying to paste stuff out, today's what, Thursday? So today we're finishing up the midpoint. Tomorrow will actually be midpoint and distance formula stuff. And then Monday we're going to review a bunch of it. And then Tuesday we're going to have a quiz over, 1.2, 1.3, and 1.7. Again, the reason why I'm skipping a few things here and there, or moving stuff around, is that sections 1.4 and 1.5 deal with angles, and then 1.7 goes back to segments. So, call me crazy, but wouldn't it make more sense just to keep working with segments since we're working with segments all at the same time? So, I figured I'll try it, see how it goes. So we'll have a short quiz on stuff on Tuesday, and then on Wednesday we'll start angles through the rest of the end of the week. Then we have the 3-day weekend. We'll probably be done with chapter 1. Labor Day's coming up? After next week, we have one more full week. And then, so we'll probably have our first test. It'll be after Labor Day. I don't see especially before that. Okay? So let me give you some problems then. I have it. Hi, Daddy. Try and keep up with me sometimes. I tell you. So same page was on page 24. I want you guys to do numbers 15 through 18. 20 through 22. I think the other one was 39 and 40. Okay? Yes, sir. If you want, I've got the textbook up here if you want to take a picture of it, or if you want to use your Chromebook now and go for it, and then do that. Yeah, add that to the problems you guys did for me from last night, those first 5 or 6, or I think it was. And then we'll collect the stuff tomorrow, and we'll talk about the actual distance formula and midpoint stuff tomorrow. Okay? Yes, sir. Depends on what it is. I have no idea. Yeah, go right ahead. I'm sorry. No, I seriously. If it's really you have it. Look, I'm like, all right, maybe I'm kind of because there's a line. I Yes, sir.